Hey there. Welcome back to another episode of Algebra in Words, the video series. What we're going to talk about today is we're going to go over some of the algebra basics. What I have on the board here for today are some of the basics like factors and terms, expressions versus equations. What does degree mean? Degree of a term, or degree of an equation, or even an expression? How can you tell the number of solutions of an equation? What do the number of variables indicate? And also, a question that many people probably don't think about too much, and the books don't go over as explicitly as I will, what is x? Alright, so let's get started. If you want to follow along with all the material we go over today in written form, you could follow along with it in my book, Algebra in Words, which is on Amazon, and I have the link posted below. Okay, so let's get started. First of all, if you notice here, I have some random terms. Alright? The first thing that I have written here is factors versus terms. What's the difference between a factor and a term? Well, it's important that we understand the basics of that, and here's what it is. A factor is a number or a variable that's grouped together, that's multiplied together. Alright? When we went over order of operations problems, we might have seen the dot, or even you may have seen the x when you did multiplication in elementary school. But from here on out, when two factors are right next to each other, it implies that it's a multiplication. So again, whenever you have a number and or a variable, could be multiple variables, next to each other, they're each factors. But then when you split up groups of factors by pluses and minus, each group, each thing that's split apart by a plus or minus is a term, represents a term. Alright? So now that we know that, this would be a term. The factors that make it up would be 9 and x. This would be a term. The factors that make it up would be 4 and x cubed. Alright? And so on. So what we're going to do next is, this is going to be a small lesson in combining like terms. That's why I have these sort of random, but they're there for a reason, terms that are scattered up on the board. Alright? So, how do you know when and how to combine like terms? What is a like term? A like term is a term or a set of factors next to each other. And what makes them alike is they have a common base and a common exponent. Alright? So let's analyze these and look for like terms. Okay, so we have 9x, we have 4x cubed, we have 2x squared, we have negative 18, we have x squared, minus 6x, and minus 4x cubed. Alright? So again, what do we want to look for? We want to look for, first let's look for the like bases. The bases would basically be, in this case, the same variable. Well, so far, this, not the 18, but this, and this, they all have the common base of x. But that's not enough to constitute a like term yet. We then have to look at the like exponents. Okay? So if they have the same base and the same exponent, then they would make a like term. Right? And I just want to point out that this does not count. Okay, I just want to point out that this does not count the coefficients. Right? Whenever you have a number in front of a variable, that's an unwritten 1, that's a 6 and 4. Whenever you have a number in front of a variable, that's the coefficient. Whenever you have a number alone with no variable, like the negative 18, we would call that a constant. Okay? Still a term, but alright, so anyway, let's now start to look for like terms. We have 9x. Let's look for a like term with 9x. It would have to be a term that has x and also the same exponent, which in this case is a 1, and when there's an exponent of 1, it's unwritten. It's assumed to be 1. Well, it can't be this because this does have base x, but it's got an exponent of 3. It can't be this because it has an exponent of 2. It can't be this. This doesn't have a variable. What about this? It can't be that. It's got an exponent of 2. What about this? It is a like term with 9x because it has the same exponent of unwritten 1. And finally, the x cubed is also not a like term, not the same exponent. Alright, so what I'm going to do with a marker is I'm just going to sort of circle and indicate what the like terms would be here. So we would have this term with this term. We would have the 4x cubed with the negative 4x cubed. Okay, notice that I'm keeping the sign with the term. Then we have 2x squared and x squared. And finally, the negative 18, there's no other like terms with the 18. If there were, they would just be other numbers with no variables attached, or as I said before, constants. Okay, so now that we identified the like terms, how do you combine like terms? Well, that's easy. You combine like terms by adding or subtracting the coefficient in front of the variables. So if we're looking to combine the like term of the x's, 9x minus 6x would make 3x. 4x cubed combined with negative 4x cubed cancels out to 0 because 4 minus 4 is 0. And then 2x squared plus x squared, 2 plus the unwritten coefficient of 1 would be 3x squared. Notice that the x squared is not changed. It stays x squared. In other words, we're not adding or doing anything to the exponents. It's staying x squared. And finally, the only term that's left is the minus 18. Okay, so we combined like terms. That's done. Before we get to expressions versus equations, I want to go over another thing which is called order or descending order. What does descending order mean? Well, descending order means from here on out, you want to have all of your terms arranged from highest exponent on the left to lowest exponent on the right. Okay, and it may not make much sense to you yet, but as you go down the line through your algebra courses, you're going to notice that having all your terms in descending order is going to be very important and very helpful for many reasons, but particularly for factoring and for solving. Okay, there does need to be order to the math. Let's put these terms in descending order. All right, let's focus on the exponents. Well, this is an unwritten exponent of 1. This is exponent clearly of 2. And we could say, since this doesn't have a variable for now, it doesn't have an exponent either. Okay? So, but actually, for the sake of argument, let's call the exponent 0. I'll explain what the exponent of 0 means later, maybe in the next video. So it's going to be 3x squared from this term in front plus 3x. That would be this term now going in the middle because the exponent is 1. And finally, the negative 18 because, again, it has no exponent, but for now we should say it's got an exponent of 0. So it goes 2, 1, 0. All right? So let's pause on that for a second, and now let's talk about expressions versus equations. And there's a reason why I have all this here and why it led up to this right now. Right now, this is an expression. We could call it a quadratic expression, but again, we'll get into more of that later on. In the meantime, what's an expression? What's an equation? Easy. An expression is a string or a sentence of terms with no equal sign. Notice this has no equal sign right now. If we put an equal sign, and in this case, if we set it equal to 0, then it becomes an equation. Okay, so we have an equation, and I am going to give the answers in a little bit. We're not going to go through the method of solving this. That's for a later video. But that does bring us to our next point, which is degree of either a term or an equation, or even could be an expression, but we have an equation up on the board now. What does degree mean? Degree refers to basically the highest exponent or the sum of the exponents within a term. And just for demonstration purposes, I paused the video and I put one term up on the board, 5x squared y cubed z to the fifth. All right, and we're going to analyze this term just to figure out the degree of this particular term. And like I was saying, all we need to do to find the degree of a term is to add the exponents of the variables. 2 plus 3 plus 5. The degree of this term would be 10 because we added the exponents of the variables. I erased that, I paused it and erased it, and let's look back at this. This one, we're going to look at the degree of each term. It's not going to be as complicated as the one I just erased because there's only one variable. If we looked at the degree of this term, it would be 2. That's the sum of the exponents of the variables. There's only one variable, and the only exponent it has is 2. So the degree of that, I'm going to write in green right here, is 2. What about this one? The exponent of the x is 1. It's an unwritten 1, but it's 1. The degree would be 1. And as I sort of talked about a minute ago, what would be the degree of the negative 18? Well, there is no variable. For a reason I'll explain soon, when there's no variable, we could say it has a degree of 0. Okay? So now, that's the degree of a term. But what about the degree of an equation or an expression? How do you find that? Well, that's also very easy. All you have to do is choose the highest degree of each term. Okay, so you find the degree of each term individually, and you just compare them, and you just choose the highest. In this case, it would clearly be 2, because 2 is bigger than 1, and 1 is bigger than 0, obviously. Okay, but one thing that I want to point out, a common mistake, at least for beginners, as you get more into algebra, you'll get much more accustomed to this. But for beginners, it's important to understand that when you're finding the degree of an equation, you do not add the degrees of the terms. Okay? You do add the exponents of variables within a term to find the degree of a term, but you do not add the degree of the terms to find the degree of the equation. Okay? Same goes for an expression. You would not find the degree of an expression by adding the variables, by adding the degree of the terms. So anyway, the point is, if I asked you, what is the degree of this equation, the answer would be 2. Okay, so what does degree tell you? There's a few things that it tells you, but there's one main thing that I want to explain about what it tells you. And again, this will all tie together more and more as you go through algebra, but it's good to know what degree means, and here's what it means. The degree, it also, one thing it will tell you is the type of graph or the shape of the graph. That's something we'll get into later. But in terms of the basics, an even more basic answer is, the degree tells you the maximum possible number of solutions to an equation, okay? So if the degree of this equation is 2, because the degree of the highest term is 2, that means that this equation, the maximum number of solutions that this equation can have is 2. That means it could have 2 answers, it could have 1 answer, it could have 0 answers. But the most that it can have is 2, all right? And just because it has a maximum possible number of solutions of 2 doesn't always mean that it's going to have the max, but it can at least have that amount, all right? Going through this series, I'll show you many different examples and situations where a problem like this could give you 2 solutions, 1 solution, 0 solutions, or even a different type of solution when we get to complex numbers. But that's for a later time and video. There's one other thing that I want to discuss here, which is, because this is a sort of an introductory basics video, number of variables. Okay, what do I mean by that? I'm going to pause the video and put something else on the board. Okay, so if you notice, I put up a little mini problem here. 2x plus 3y is equal to 14. Now, in this problem, there's only x's. They are to different degrees, but there's only x's. But in this equation, there's x and y, two variables, okay? What's the point that I want to make about the number of variables? Well, you need as many equations to solve for as many variables or unknown variables as you have in an equation. So for example, in this problem where we have only x's, we only need one equation to successfully solve that, to find x. Even though there could be more than one answer for x, there's going to be a maximum possible number of answers of 2 answers. However, for 2x plus 3y is equal to 14, there's not enough information for us to solve this by one equation alone. The answer to this is, for the amount of variables there are, you need that many equations to solve it. Since this has x and y, two variables, we would need another equation, a total of 2 equations, to find the answers to x and y. Okay, so I erased that example, but back to this problem and to continue on. I'm not going to get into the solving method right now because that's for a later time in video. However, I am going to tell you what the answers are to this, and the answers are x equals 2 and x equals -3. Alright? So, we're almost near the end of this video, but with all that being said, I want to continue to analyze this and even discuss what is x? Okay, yes, it's the answer. Yes, we just solved it and found it to be numbers, but what is x? Alright? Alright, so I paused the video and I drew a very basic graph. We don't need to get into graphing right now, but I wanted to just give a brief visual. And this graph that I'm about to draw is not going to be perfect, but it's going to basically do the job to make my point. And my last question was, what is x? Well, ultimately, you should know that equations are very closely related to graphs. Basically, they're just representations of what the graphs will be and vice versa. Alright? And even though you may not be required to do graphing from equations right away, ultimately you will, and in my opinion, it's good to know conceptually what the equations represent in a graphical, visual, conceptual sense. What is x? X, the answers or the x values are called x-intercepts. Basically, it's the point on a graph where the line crosses the x-axis. The x-axis is this line, and it's the horizontal line that you'll get into that much more later, and we'll do graphing more later. But assuming this is the x-axis, we can plot and find these x values, or as I just taught you, x-intercepts. Alright, if x equals 2, we start at the origin and count positive 2 units to the right, and that point would be here. And for x is equal to -3, the other value, we start at the origin and count 3 units to the left, and we plot that point, and that would be point -3, 0, and again, this point would be 2, 0. So, and if we wanted to graph this, again, it's a basic sketch. I didn't do all the details for this, but long story short, as we figured out, this is a 2-degree equation. A 2-degree equation is a quadratic equation which produces a parabola. This is a parabola. Again, you'll get into that later, but this is just to demonstrate that from all these terms and all that chaos can be rearranged, ordered, put into descending order, made it as an equation, solved. You can find the answers or the x values. The x values represent x-intercepts, which can be plotted and ultimately graphed. Alright? So in this video, we covered quite a bit. We went over the difference between factors and terms. We went over expressions and equations. We went over the maximum number of possible solutions that an equation tells you it could have. We told you the number of equations you need to solve with the same number of variables. And finally, we went over what does x mean, the x-intercepts. Alright, so that's the end of this video. In the next video, we'll go over some exercises and practice problems together. But thanks for watching. If you like this video, please give it a thumbs up. Please share with your friends, and also you can check out other videos on Facebook and Instagram. And I'll see you on the next video. See you later.